Hello everyone, welcome to Magician Technical Training Hub powered by Dice Controls. Let me ask you a simple question. Today, AI tools like ChatGPT, GitHub, Copilot can generate any program just in a seconds. So now the question is, why should we learn any programming techniques? The answer is simple. AI can write code, but software engineers choose the right solution. For example, every day we will be doing some Google search. We will be finding some products to order on Amazon. We will search for movies on Netflix. Have you ever wondered how these applications find exactly what you are looking for within seconds? The secret is searching algorithms. As developers, our job is not just to write code. Our job is to understand the problem, choose the right algorithm, and make sure the solution is fast and efficient. In today's session, we will learn two important searching algorithms, linear search and binary search. Don't worry if you are a beginner, we will first understand the idea, then we will implement it by using AI. Let's get started. Let's begin with our first searching algorithm, linear search. Imagine you are searching for your house key inside a bag. The items are not arranged in any order. You will naturally check one item after another until you find the key. That's exactly how linear search works. Now look at the array. We have 5, 3, 8, 4 and 2. We need to search a number 4. The computer starts from the first element. It compares 5 with 4. It will be not matching. It will compare with the 3. It will compare with the 8. And finally, it compares with the 4. So the match found. The computer immediately stops searching and returns the index of that element, means of that 4 is 3. How? The index of 5 is 0. So 3 is 1, 8 is 2 and 4 is 3. So it will send the 3. So remember the logic. Start, compare one by one, match, return index. So you are started with the first element. You started to compare the first element with the second, first element with the third, first element with the fourth until you find the match. And then finally you stop with the search and then you allow program to return the index. Linear search in any programming language can be achieved by 7 steps. First, a programmer should have an array of numbers which is not sorted, and programmers should know what is the target value to be searched. Programmers should have linear search array, which is called as a method or a function which is accepting the array and target as a parameters. The logic is, if the method returns -1, then element is not found. If it returns other than -1, then element is found. The main decision will happen through looping each and every element from first index to last index by comparing using if condition. Now let's learn a smarter searching technique called binary search. Unlike linear search, binary search does not check every element. Instead, it follows one simple idea. Find the middle, compare, eliminate half. Repeat the process. Look at the array. Notice that the numbers are already sorted. This is the most important rule. Binary search works only on sorted array. Suppose our target is 22. The computer first finds the middle element. If the middle element is the target, the search is complete. If the target is greater than the middle value, the computer ignores the left half and searches only the right half. If the target is smaller than the middle value, it ignores the right half and searches only the left value. Every comparison removes almost half of the remaining elements. That's why binary search is much faster than linear search. So remember the concept. Sorted array, find middle value, compare, go to left or right, repeat the process until you get the target match. Now let's understand how the computer makes this decision for calculating the binary search. We use three variables in this program, like we have to have low, starting position of the array, high, ending position of the array, middle position of the array. The computer asks where is the middle of the current search area. Then we have a formula. How? Middle equal to low plus high minus low by 2. Don't memorize the formula. Just remember that it will always find the middle of the current search range. Now, the program compares the middle element with the target. If they are equal, the search is complete. If the target is greater than middle value, the answer can only be on the right side. So, we move low equal to mid plus 1. If the target is smaller than the middle value, then answer can only be on the left side. So, we move high equal to mid minus 1. Now, you may wonder, we use a while loop instead of for loop. Because in for loop, we should know already how many times we need to repeat. Whereas while loop is used when we don't know how many iterations are required. In binary search, like we have to keep repeating until the element is found or there are no elements left to search. That's why a while loop is the perfect choice. So remember the binary search logic, low and high calculation, find the middle value and then you have to start compare. If the match is exactly at the middle, the program can end there itself. Otherwise, if it is greater than or less than, move to left or move to right, repeat until the result is found. Linear search versus binary search. There is one simple way to remember the difference. Linear search as is this is the number. Binary search as which half can I ignore? That's the biggest difference between these two algorithms. So the real thing is we are entering into a new era of software development. AI can generate code in seconds, but AI cannot replace problem solving. The future belongs to developers who understand algorithms and know how to work with AI. Today, you did not just learn two searching algorithms. You learned how a computer thinks while solving a problem. Thank you for watching. If you found this video helpful, don't forget to like, share and subscribe to Magician Technical Training Hub powered by Dice Controls. Thank you.